All right, welcome. We are the Characteristic Lake Autonomous Monitor Team, wonderfully abbreviated as Clam. I'm Michael, it's John, Keshav, Katie, and Jake. Now the idea of our project centers around the idea of lake health. Now there's hundreds of thousands of lakes in the United States, all of them with their own unique ecosystems. And so monitoring these characteristics over a long period of time can be very labor intensive, meaning someone has to travel to that lake, take the samples, take images, and report that back to the end user. So what our goal here is to create an autonomous system that goes out and exists on the lake and takes these readings and then transmits them back remotely.
So our key product requirements, we have 5 big requirements. Our first one is we have to be able to navigate autonomously. So we have to be able to get from one location to the next to get a full baseline of the lake. Our second key one is we have to be able to monitor the lake and know what makes a lake healthy. So we chose to do a macroecological scale there. We're looking at wildlife and audio. Our third big requirement is we have to be able to send all this data remotely. So once we have the data, we have to be able to get it back to the people who make decisions. Our final two, to have a sustainable power system. So this is fully solar powered, so it can stay on the lake for about 9 to 12 months, which our last requirement is to stay out there for about a year.
So we selected a kayak as the base of our bot because it's sturdy and it's very durable. We are powered with a solar panel connected to a deep cycle battery so that it can last for a long time by itself in the water. So we have lots of different sensors connected to the brain. We have a pH sensor, a camera, and a microphone for measuring the water quality and also taking pictures of wildlife, taking recordings. And these are all connected to our central brain, which is a Raspberry Pi here. And the Navio controls the navigation, which is connected to a servo on the motor, so it can spin in the angle that we want it to navigate to. Yeah, and so all together it creates the Clam.
So a lot of our design challenges revolve around the difficulty with keeping a system like this around on the lake for a whole year, and also it is broad scope for the operation, and so we have lots of subsystems that have to come together to get this to work. So we have a power system, a communication system, sensing, and navigation, and the body. They all have to work together for this product to really get the data that it needs to back to the end user. So a lot of our struggles revolve around getting those to talk to each other, also to make it a modular system to be expanded upon, because every lake is different. So what is good lake health for one lake might not be perfect for another lake. So we want to make it so people can add their own equipment and sensors that they need for their particular lake. And additionally, we need a reliable sense of communication with the lake bot so that we can get the data back from it, all the pictures, the audio, all that data, and also to send new commands back to it so that it can change the route even after it's been deployed.